Hello, this is a video for HA Psychology A-Level, Paper 2, Section B, Biopsychology, and today we're going to look at Ultradian rhythms, that is part of the biological rhythm section. Just as a reminder, when we talk about Ultradian rhythms, we mean those rhythms that occur cyclically more than once a day. So it could be your heartbeat, it could be your meal times, it could be your blinking. All these things happen more than once a day. However, there's not a lot of depth in explaining those. So what we're going to focus on today for ultradian rhythms is the stages of sleep, and specifically REM and non-REM, so all the stages of sleep. Each stage of sleep is an ultradian rhythm. So your AO1 will be the description of every single stage of sleep, and then your AO3 will be looking at evidence mainly for how it is true that sleep is not one big chunk, but actually it's got stages within it that are qualitatively different and that have different functions. That is your proof that sleep is not only a circadian rhythm, but the stages of sleep are ultradian rhythms. And we'll also look at the evolutionary value of specific stages of sleep. So just a reminder, sleep is a circadian rhythm, as in the sleep-wake cycle is a circadian rhythm. However, the different patterns that occur during the sleep-wake cycle happen more than once in the night, and therefore they are ultradian rhythms. The sleep-wake cycle is circadian, the stages of sleep are ultradian. The stages of sleep are studied using EEG, electroencephalograph. So we see different waves that, as you can see, if they're very close to each other with a low amplitude, like these ones, they suggest that the brain is very active. As sleep develops overnight, you see how the activity is slowing down. You've got these K complexes, and then you've got these theta waves that become slower and slower as the night progresses. And here, what we call slow wave sleep, stages 3 and 4, where the brain activity is really to a minimum. So you need to know about the different stages of sleep. You need to know that there are 5 and that they're not all equally distributed. As you can see, there are some stages that occur much more often during the night, like stage 2 and stage 5. Stage 2 is light sleep, stage 5 is REM sleep. That is what we're going to be focusing on the most. It's not enough to describe the stages of sleep, you also want to go into more detail. The deepest sleep occurs early in the night, so there's those slow wave, stage 3 and 4, happen more earlier in the night. However, as the night progresses, you get more and more REM sleep that we'll focus on in a minute. Natural waking also seems to happen during REM, and if you look at the brain waves, there's a lot of activity in REM, meaning you're more aware of the sounds around you, the sensations around you, and that might be what wakes you up. Each cycle takes about, you can't see it here, but it's 90 minutes. And therefore, because we sleep more than 90 minutes per night, it's an ultradian rhythm. It occurs more than once. As I mentioned before, description of the stages is not enough. You can't just describe stage 1, this happens, stage 2, this happens. You have to be able to outline an example of one or more ultradian biological rhythms, for example, the REM and non-REM. So it's also important to not only know about one, but to know at least about 2. And look at this in red. For marks in the top band, you have to be able to provide details of the alternations. For example, how many REM episodes are there, how many, in what sequence do they occur, and what makes them different from the other stages of sleep. So here we go. This is answering that question. Sleep begins in stage 1, so almost still awake, lots of brain activity. Then it goes into stages 2, 3, and 4, so go into deep sleep. But then after stage 4, then you go into stage 3, so you go backwards into stage 2, and it's when we were in that kind of lighter stage of sleep that REM starts happening. And as we've already seen, REM gets proportionally bigger and bigger as the night progresses, whereas stages 3 and 4 get smaller and smaller. So slowly there's a transition where there's less deep sleep and there's more REM sleep. Every alternation into REM and out of REM goes back to stage 2, and that can explain why in the previous slide we saw that stage 2 was almost more than half of our total sleep time. So now we're going to look at the peculiarities. So that's the next requirement in the mark scheme. What makes REM different from the other stages of sleep? First of all, we've got these beta waves that are like alpha waves, and alpha waves are wakefulness. So the brain looks almost awake in REM, but you're completely asleep. Okay? EOG is the electroocular graph that shows the eye movement, and that's where the name REM comes from. It's rapid eye movement. What has been observed is that the movement of the eyes seem to correlate to the content of what someone is dreaming. So if you were dreaming about a giant or a monster, your eyes might be looking up. If you're dreaming about being chased, your eyes might be looking right and left to check if someone's right behind you. Okay? EMG is electromuscular graph, so it's showing your muscle movement, and it shows that there's paralysis. So technically, we can't move if we're in REM, and that makes sense because we'll see that what's special about REM is that most of our dreams happen then. And if we could move, we might live out our dreams while we're sleeping, and that's called sleepwalking, and it's very, very dangerous. So it's actually a sleep disorder. And pulse, respiration, and blood production become irregular. So in deep sleep, you'll hear quite deep breaths and very regular breaths, but it becomes irregular during REM because it's a much more active stage. Okay, so that should be enough for your AO1, describing the stages, describing the sequencing of the stages, and then focusing specifically on one of the stages and how it stands out and it's very different from the other stages. In fact, it's so different that all the other 4 stages of sleep are classed as non-REM, as opposed to stage 5 that is REM, and that shows you how special it is compared to the others. So there's a very famous study by Dement and Kleitman, very simple but very smart, where they had people in a sleep lab sleeping, and all they would do, they would have a standardized procedure where they woke them up randomly, either during REM sleep, because they could see from the EEG that they were attached to whether they were in REM or not, and they asked one simple question: were you dreaming? Yes or no? And if they said yes, they would ask about how long they thought the dream was. And as you can see, REM is much more likely than non-REM to be the time when people dream. 80% of the times they were woken up in REM, participants reported to be dreaming, and in only 15% of cases, that is not statistically significant, they reported not dreaming in non-REM. That suggests that the stages of sleep are, in fact, qualitatively different, that REM is, in fact, an ultradian rhythm in its own right, with specific qualities that don't transfer across the other stages. Now, we know that sleep has value in our survival and in our kind of efficiency. Sleep helps clean the brain, cerebral spinal fluid, reduces toxins and products accumulated during the day, and flushes them out, helping to maintain cognitive function and also potentially reducing the risk of dementia, Alzheimer's, meaning that, and we can see it in the next slides, sleep deprivation can at best cause cognitive impairments, that at worst it can be fatal. Now we're going to look specifically at REM because the previous one was about sleep in general, so let's be careful because sleep in general is not necessarily an ultradian rhythm, so we transition straight into the role of REM and slow wave sleep, so two specific stages of the sleep, and therefore can be classed as ultradian. In terms of consolidation and cognitive function, we identify REM and slow wave sleep as the most important. Reorganizing neuroactivity happens in those kind of high quality stages of sleep. So as you remember, only a small proportion of our sleep is in fact qualitatively different than just resting. Stages 1 and 2 are not really important, but a big proportion of our sleep is stages 1 and 2. Now, that said, we know that if someone engages in something very complex cognitively, like a test, problem solving, then the sleep that night seems to have a bigger proportion of REM, again proving to us that REM is qualitatively different and is of great importance in terms of consolidating and restoring the brain. And therefore, the brain will automatically prioritize REM sleep if we've strained the brain in the daytime. It's also observed in people who have had a brain injury or an overdose that they will also experience above average proportion of REM, proving the qualitative value of REM. Now, lastly, we're going to look at the sleep stages in animals. The idea is that if REM promotes survival, then we should observe it in animals. And in fact, we can see it in mammals and birds. Yes, we see REM sleep. Some reptiles do show evidence. So this, again, the reptiles having REM sleep, or some evidence of REM-like sleep stages, suggests that this is an ancestral component of our brains that promotes our survival. There are differences between different animals and the extent to which they're experiencing REM. For example, we don't see REM in fish, but we do see sleep-like states in fish. And also certain invertebrates also display REM-like behaviors. So altogether, this shows us that REM-like states have been here since the beginning of time almost. And that brings us to our last point, that is the evolutionary value of sleep. All species sleep, so sleep must have valuable function. Rats deprived of sleep die after 33 days, and also volunteers who are gradually deprived of sleep, and this is humans, will have the majority of their sleep, or a big proportion of their sleep, will be REM, again suggesting that when our brain needs to be restored from sleep deprivation, it will go into REM, not stages 1 and 2. It will kind of transition quite quickly into that REM.